Hello everybody, this is Tanushka Marit and I'll be presenting K-means clustering and supervised machine learning as a part of my task at the Data Science and Business Analytics Internship under the GRIP, that is the Graduate Rotational Internship Program. I was very glad to be a part of this program. The task I have been given here is from the given iris dataset, predict the optimum number of clusters represented visually. So as I actually move forward, let me just talk about a bit in brief about K-means clustering. K-means clustering is by far one of the most popular unsupervised machine learning algorithm. And when I actually say unsupervised machine learning, I basically mean that I focus more on the fact that it's a concept of an unlabeled data. So it groups unlabeled datasets into those clusters, and that's the reason I'm having K, which actually predetermines what the value will be, as in the number of predefined clusters which will be created. Like in case K could be an arbitrary value of 2, so it basically means that 2 clusters will be created. If K is 3, 3 would be created, and so on. So moving forward, this entire thing, that is a K-means clustering, basically consists of 2 tasks. One is determine the best value of K centroids, that's by using a kind of an iterative process, and second is assign each data, which actually the data point which could be then a data set, a given K center point. That is when I actually categorize one particular data point as a part of a certain centroid, and gradually it creates a cluster of that particular K center. So thus different kind of clusters are created. So moving forward with the code, here I mean import library, so it will import the required number of libraries. Import NumPy, Pandas, Matplotlib and sklearn. So it will actually help me NumPy for the mathematical computations, Pandas for data pre-processing purposes and data frame managing the data, etc. Matplotlib.pyplot for data visualization, and this is for dataset management. So whenever we actually begin with any predictive modeling algorithm, so we start with data preparation, or it is alias it's also called data pre-processing. And once I start with data pre-processing, I import the iris dataset. In this case I'm using load iris, which actually helps me import this in the form of a data frame consisting of 4 columns, that is sepal length, sepal width, petal length and petal width. This is the df.iris head. Finding the optimal number of clusters, and as I mentioned previously, it's very important. In fact, it's the first of the 2 tasks. Determine the best value of K centroids using an iterative process. So that's what I actually use. I use sklearn plus K-means. Here I'm having the iterative process, that is I in range of 1 to 11. So it will actually loop from 1 to 10, and thus for each particular value of this I, the WCSS will actually be created. And that's the reason WCSS basically means within cluster sum of squares. And for finding the efficient way for finding an optimal number of clusters, or rather the optimal value of K, would be using an elbow method, which I've implemented here. The WCSS value is a within cluster sum of square value, which helps me define the total variations which could actually be present in a cluster. So the basic steps which are involved in the elbow method step to actually summarize would be, for different K values, I calculate the WCSS value, it appends it, and then accordingly with the calculated values of WCSS as well as the given value of K, we would actually help in plotting this entire thing, that is the number of clusters versus the WCSS. So that is exactly what I do. That iterative process is executed. I have my WCSS in the form of a list ready, and then I'm using a plotting function, a linear graph, to observe the elbow, because as the name itself suggests, elbow basically means a sharp point or a particular bend which I actually find over here. That gives me an optimal value of K. And so in the graph shown below, the WCSS is labeled as my y-axis, and so it's a WCSS versus the number of clusters graph. I create a K-means classifier, that is I train the model to fit the given data set. The training part is done here, and thus K-means is equal to K-means n clusters 3. So the format remains the same for creating the K-means classifier, but the only thing is, instead of I, my optimal value, that is 3, will actually be inserted in this position. And so I'll use this fit predict. Then finally I go on to the visualization part, and when I visualize the cluster data using some scatter functions, So that's the reason it shows me three distinct clusters which have been shown using red, blue as well as green. Which is representing Iris setosa, Iris versicolor and Iris virginica. Plotting the centroids of the cluster as well as the cluster visualization have been done for clarity and unambiguity purposes. That's the reason here it's depicted with the help of yellow, the three distinct centroids. Finally, I have a combined cluster visualization, which helps me show and plot the centroids of cluster along with the cluster visualization, and thus here the last visualization, data visualization, which consists of the three clusters. As k was equal to 3, the optimal value we had found along with the centroids have been plotted here. Red shows my Iris setosa, Iris versicolor by green, as well as blue, which denotes Iris virginica, along with the yellow as my centroids. Thank you so much. I hope I've been able to give a really satisfying and a lucid explanation for the work which I have performed. I was absolutely glad and excited to do this as a part of my internship, and I'll be willingly and ready and more enthusiastic for future projects. Thank you so much. This is Tanishka.